All right, yesterday we talked about side, 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 and side, angle, side. Today we're talking about angle, side, angle, and angle, angle, side. Okay, first one we're going to focus on is angle, side, angle. I'm going to compare this one to side, angle, side. How do they relate to each other? How are they different? It's kind of just opposite, right? What's in the center of side, angle, side? The angle. What's in the center of angle, side, angle? The side, okay? So we can use those to help us remember what's in between what and what it should look like in the picture, okay? Like I said, we're used to congruence markings, not numbers, okay? So if I say 3 is congruent to 3, what else can I say? 45 is congruent to 45, and 25 is congruent to 25. So do these two triangles satisfy angle, side, angle? Yes. So since it satisfies angle, side, angle, what does that mean for the rest of the triangle? Everything else is congruent, okay? So angle, side, angle works just the same as side, 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 and side, angle, side. Okay? Let's look at example 2. Here. Do these two triangles satisfy side or angle, side, angle? Yes, I agree. Angle, side, angle. Write a congruence statement to this. So write this triangle is congruent to this triangle. Any congruence statement about those two triangles. Okay, how many of you copied the one that they already had? How many of you just wrote this down? Okay, does it have to be that? No. When you're writing congruent statements, by the way, this is a congruent statement, okay? When you're writing congruent statements, does it matter the order of the first one? It does not. Does it matter the order of the second one? Yes. Why does that one matter? Right. It has to match up with the first one. So in our picture, I'm just going to use L for example. We said L is congruent to O. Is that true with this statement right here? Yes, because they're both the third one mentioned. Okay? And then specifically LK or KL is congruent to ON or NO. Is that true? Yes. Okay, so if I ask you to write a congruence statement, it is something that looks like that. Okay? Looking at, go ahead and flip your notes. Example 3. I want you to try that one on your own. 3A and B. Looking at example 3A, it's asking if JKL and MNO are congruent to each other. If so, why are they? Are they congruent? By angle, side, angle. Okay, I agree. Now looking at example 3B, it's asking about these two triangles. Are those two triangles congruent to each other? Why not? It's not in the order, right? This one follows the order, but does this one? No. On that triangle number 2, where would that side have to be? Yes, in between here. Okay, another question I'm going to add, you don't have to write this down. Is triangle MNO congruent to triangle PQR? No. Why? It's the same argument, right? Would I need, if I knew the answers to 3A and 3B, would I even need these pictures? Why not? If I knew that these two triangles were congruent and these two were not, why would I already know the answer to this one?
Because JKL is congruent to MNO.
And MNO.
It's the same. And then, so they're the same.
Right. These two triangles, you already said they're the same. So if JKL is not congruent to PQR, can MNO be congruent to PQR? No. Okay, so keep in mind all of those relationships when you're comparing triangles. Okay? Go ahead and flip your notes. We are now going to look at our last property, angle, angle, side. Okay? Again, does order matter? Yes. So looking at these two triangles, do they go in the order of angle, angle, side? Looking at example 4. They do. This does satisfy angle, angle, side. Write a congruence statement that satisfies those two triangles. All right, someone tell me what you had. What'd you put for the first one?
Triangle JKL is congruent to QRP.
Good. Did anyone write something different than that? So you just flip-flopped them? Okay. Which one doesn't matter how you write it? First or second? Doesn't matter about the first. The second one matters the order. Okay, it's got to match or correspond with the first one. Good. Go ahead and do 5, A and B on your own. Okay. This is not in your notes, but I want to look at this real quick. On this first one, do you agree that those two triangles are congruent by angle, side, angle? Clap once if you agree. Let's try again. Clap once if you agree. There we go. This one, do you agree those two triangles are congruent by side, side, side? Clap once if you agree. Okay. This one, angle, angle, side. Clap once if you agree. Okay. This one cannot be determined. Can you do that? Clap once if you can do that. If you can say it cannot be determined. Clap once if you agree. Okay. Some people would argue side, angle, side on this one. But why can it not be side, angle, side? It's got to be in the same order. It cannot jump. Okay. What information do I need to add to this one for it to be true?
Another angle and
Right. I can put an angle here, or I could put a side over here. So remember, it is okay to have cannot be determined. Out of those 4, which one is the easiest to see?
Side, side, side.
Side, side, side. Did I tell you that yesterday, that one's going to be your favorite? Yeah. Okay. If you see 3 sides that are the same, automatic side, side, side. All right. Let's about example 5. What additional information is needed to show that the two triangles are congruent by angle, side, angle?
They need another angle measurement.
Specifically where? B and E. So your answer should be angle B should be congruent to angle E. Then it would be true. Okay. For part B, it wants us to prove angle, angle, side. What do we need?
another angle at point C and F.
Yep, C and F. So angle C should be congruent to angle F. Looking at your congruent statements here, do these match up? Should B be congruent to E?
Yes.
Yes, because they're both the second one. Should C be congruent to F?
Yes.
Yes. Okay, good. Go ahead, Flip. One thing to talk about. What do you notice about example 6?
Math.
There's math going on. What else do you notice? They're not triangles. Can we use those 4 properties with shapes that are not triangles? We cannot. Keep in mind, you can only use those 4 properties with sides and angles with triangles. Okay? So with this one, what does this sign tell us right here? Tells us that they're congruent, which that means what? They're exactly the same. So, and keep in mind this congruent statement here, we want to solve for x. Well, x is on side EH. What side on the other shape is congruent to EH? A, D. I agree with you. How many of you looked at the picture to determine that? How many of you looked at the statement to get your answer? How many of you guessed? How many of you don't want to answer the question? Okay, so remember, you can figure out what is congruent to EH by the congruent statement. So EH is here, so it has to be congruent to AD. Or you can just visually look at it. All right, to solve for x, if we know these two are equal to each other, how can we set up an equation to solve? 2x minus 3 equals 9. Two-step algebra, how do I solve? Add 3 to both sides. So I get 2x equals 12. Next step, divide by 2, x equals 6. If it wanted the value of that side, what would you do? Plug it in. Good. Yep. Now, keep in mind, you know all 4 of these now. Okay, so just because we're in this lesson does not mean that side, 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 and side, angle, side does not exist. Capiche? You know all 4 of those now. Number 1, what do these two properties, if they satisfy, tell us about triangles? That they're congruent, which means what?
They're the same.
They're exactly the same. Okay? On number 2, he's saying that, first of all, what kind of shape is this? This one right here. It is a trapezoid. So he's saying B and C are congruent and A and D are congruent. So he's saying that therefore those two triangles are congruent by angle, angle, side. What's wrong with that? Right, do they even look like the same triangle? No. So can we even say they're congruent? No. So that is just wrong. We cannot say that they are congruent to each other. They are different sizes. Okay. Number 3, how can you tell which property of triangle congruence shows that those two triangles are congruent to each other?
Angle, angle, side.
Yep. Angle, angle, side. Does everyone agree? All right. Number 4, is there a congruence relationship that is sufficient to show that those two triangles are congruent to each other?
No.
I hear no. Does anybody think yes? Why is it no?
Because you can't get anything out of that.
Right, you can't get any of our 4 properties out of that. We only know a side and an angle. Okay? Remember yesterday we talked about things we can assume. When can we assume something about a triangle?
When you have enough information.
When you have enough information to assume, or remember if we talked about connected triangles? If they're connected, you can assume whatever they're connected by is the same. Okay, are these two triangles connected?
Yeah.
No, so we can't assume anything like that. The other thing we've started to assume is if we have 2 angles, what can we do with the third?
You can find it.
You can find the third, okay? So, but do we know 2 angles in order to find the third? No. So we cannot tell that these 2 angles are, or that these 2 triangles are congruent. All right, what I need from you is you can do 5 through 9, and then we'll go. 5 and 6. Like I said, we're used to congruence markings. So if you need to think of it that way, go ahead and draw those in. We want to solve for x, so we need to figure out what side is congruent to that x plus 4. What side's congruent to that x plus 4?
QP.
QP, which is 7. Good. If those are the same or they're congruent, what can we set up to solve for x?
X plus 4 equals 7.
X plus 4 equals 7 to solve? Not 4. Subtract 4, so x equals 3. There we go. Good. What side on number 6 is congruent to 4x minus 1? 15. Do we agree?
Yeah.
Okay, how can I set that up if those two are equal?
4x minus 1 equals 15.
4x minus 1 equals 15. Two-step algebra.
Plus 1, 16, divided by 4, 4.
Yep, 4x equals 16, divide by 4, x equals 4. Good. Questions on those two? All right, 7 and 8, we're stating whether these two triangles are congruent and by which theorem. Okay, what about number 7? Are those two congruent?
Yeah.
By
Angle, angle, side.
angle, angle, side. Good. What about number 8?
Angle, side, angle.
Does everyone agree with angle, side, angle? Remember yesterday we had an example that looked like this? Why can those two not be congruent? It's congruent to itself. It's not congruent to the other triangle. So then why does this one work? Right, all 4 of them are the same. These two are congruent, and also these two are the same measure. Okay, so that's why this one works and yesterday's did not. Okay, so that one is congruent by angle, side, angle. Good. What about number 9?
Because they have the same angles and then the same sides that are shown.
Okay. So you think they are congruent because of that? What are you thinking? Same thing?
You could use the congruent statement.
How?
Like, you can look at NO equals RS. You can look at the picture.
Oh, I see what you mean. So he's looking at this and he's trying to look at the picture to see if that statement is true. Okay, which I agree with you. What if can I make these shapes into triangles? that. What do I know about, let's say, these two triangles? Side, angle, side, right? Those two triangles are congruent by side, angle, side. What about these two?
Side angles.
Side, angle, side. So if both of those are congruent, does that mean the whole thing is congruent? Yes. Okay, so remember, we can make triangles out of four-sided shapes. Good.